Hello students. So, this video will be short, it better be short anyway. I only want to prove one claim, and it's a claim that in fact you can prove on your own. I want to prove the following. Claim. If xn converges to some limiting value p, and wn converges to some limiting value p, then the sequence z sub n given by x sub n over 2 if n is even, w sub n plus 1 over 2 if n is odd, converges to p, to that same limit. So let's try to prove this claim. So this is just going to be a straightforward epsilon n proof. Let's let xn and wn be sequences. Let's let zn be the sequence given by xn over 2 when n is even, xn plus 1 over 2 when n is odd, we want to show zn converges to p. And now we can start the standard setup for an epsilon n proof. So let's consider any epsilon greater than 0. I now need to come up with a choice of big N. And, well, the only thing I know is that xn and zn converge to p. So let's use that to get some choices of big N. So since xn converges to p, there exists a big N, maybe I'll call it x, such that for all n in N, if little n is bigger than nx, then absolute value of x sub n minus p is less than epsilon. Similarly, since w sub n converges to p, there exists another trace of big N w, it doesn't matter what you call them, such that for all little n bigger than big N w, absolute value of w sub n minus p is less than epsilon. Alright, well, let's figure out what to do next. So let's let big N be, and I'm going to give myself lots of space. In fact, I'll give myself the whole rest of that line. And let's consider any little n bigger than big N. We want to show that the absolute value of zn minus p is less than epsilon. Alright, well, remember what Zn is. It's this. There are cases. Those cases might break down how the proof should proceed. Alright, so let's see. Either n is odd, even first, or either n is even or n is odd. So there are two cases. If n is even, then I'm going to give myself space right here to figure out some analysis that I'll need to do. Then absolute value of Zn minus p, right, the thing that I want to show is small, is equal to, n is even. Well, in the case that n is even, Zn is x sub n over 2 minus p. Oh, but wait, as long as n over 2 is bigger than big N sub x, right here, if n over 2 is bigger than big N sub x, then x sub n over 2 minus p is less than epsilon. So let's just write that. Is less than epsilon, since n over 2 is greater than big N sub x. So that had better happen. Secondly, if n is odd, then I'm going to put some stuff right here. Then the absolute value of Zn minus p is equal to the absolute value of x sub n plus 1 over 2 minus p. And that'll be less than epsilon as long as we can get a similar inequality. Thus, either way, absolute value of Zn minus p is less than epsilon. So, for all epsilon greater than 0, we conclude that there exists a choice of big N, which we haven't really filled in yet, such that for all little n bigger than big N, absolute value of Zn minus p is less than epsilon, and Zn converges to p as we claimed. So let's now figure these out. So there are the two things that I need. I need n over 2 bigger than big N sub x. So this is scratch walk off to the side. N over 2 bigger than big N sub x. So that looks like I need little n to be bigger than 2 times big N sub x. I will need here that n plus 1 over 2 is bigger than big N sub w. So that means n plus 1 needs to be bigger than 2 nw. So n will need to be bigger than 2 nw minus 1. So I need this to be true, I need this to be true. There is what I get to assume. Well, how about if I just assume that little n is bigger than the maximum between these two things? That would do the trick, right? So let's let big N be the max between 2 n sub x and 2 nw minus 1. Neato. So let's see, in the case that n is even, then it looks like here's what we care about. So let's look at n over 2 and see what we can get. In the case that n is even, then n over 2 is strictly bigger than big N over 2, right? Little n is bigger than big N, is bigger than or equal to 2 n sub x over 2, which is just n sub x. So I know that little n over 2 is bigger than big N sub x. Full stop. Next sentence. If little n is odd, then it looks like here's what we care about. So let's try to get that. Then n plus 1 over 2 is bigger than big N plus 1 over 2. That's bigger than or equal to 2 times n sub w minus 1 plus 1 all over 2. Stare at that for a second, you get n sub w, which of course it had to. That's how we came up with our choice of big N. So I know that n plus 1 over 2 is strictly bigger than n sub w. Full stop. So that means the absolute value of Zn minus p is exactly this, which is less than epsilon because this is true. Great, so that completes the proof. I hope you found this useful. I might post this as, I'll try to post it as a PDF and, well, I'll post it as a video at least. Talk to you later.